All right. Chet? Good evening, everybody. Come on, you do better than good evening, everybody. Thank you very much. Joan has given me a script, so that makes my life really easy. But that, I guess from the heart, thank you very much for joining us. We're really excited by this. Just a couple of housekeeping things. First off, my name is Dave Franchino. I'm the president of Design Concepts. I know most of the people here. But for those of you I hope I'll have a chance to meet later on. And thanks for joining us for this little series we wanted to offer on the role of human factors in product development. A couple of housekeeping things. For those of you who are joining by phone, I look at the phone and talk louder for some reason, I guess. We can't hear you, so if you have questions to submit, if you can type them in through the GoToMeeting. I think Kurt in the back will be addressing those, and then at the break we can address the specific questions. Please, for those of you here, if you'll just hold your questions till the end, we'll have a little bit of Q&A, that's fine. There are restrooms down the hall if you need those. But now, I guess, on to the main event. It's my real pleasure to introduce my business partner, friend, Craig Connor, who's our Director of Human Factors Engineering. I'll let him introduce himself. Other than for me to say that Craig is just incredibly passionate about the role of human factors and usability in product design. It's always been one of the underpinnings of design concepts. So we appreciate you joining us and a chance for us to kind of talk about that and have a collaborative session of human factors. So, Craig, take it away. Thanks much.
Hello, everybody. Thanks again for coming out on this Wednesday night. I hope everybody's enjoying the beverages and snacks. So just by way of introduction again, as Dave mentioned, I'm Craig. I have a little bit of a curious background. I started off life as a mechanical engineer, and if it wasn't for some really bad advice I got from my freshman year counselor, I was going to double major in art and engineering. But he talked me into the fact that there's no jobs for that and no reason to do that. But nonetheless, around my junior year, I figured out that product design was what I was really interested in. So I lobbied with both the dean of engineering and the dean of the art department to have permission to take industrial design studio courses. And they really didn't want their engineers taking time-intensive studio courses. So it was a little bit of work, but really paid off for me. And you know, as I graduated from Notre Dame, I realized that this is definitely what I was interested in, and I wanted to further my education a little bit more, so I had more to bring to the table to prospective employers. So I went to grad school here at UW-Madison. I was originally drawn by a professor named Frank Franzak, who was doing great product design work in the mechanical engineering department. So as I came on board, first of all, there's no industrial design department at UW-Madison, so I kind of took up residence in the sculpture group within the art department to kind of keep that creative side alive and well and blend that with what I was learning in mechanical engineering from a product design perspective. But I really found what became my passion within what was then the industrial engineering department, which is where kind of their concentration on ergonomics and human factors lived. So for those of you that don't know, there's not a whole lot of, if any, real programs on human factors. It's usually a specialty within either industrial engineering or biomedical engineering. So that kind of became the focus of my studies and my work. And so what I really try to do is blend all three of those perspectives and try to bring that importance of the user and what their interaction, what their experience with products is going to be to the forefront of our product design process. A lot of my colleagues that are human factors practitioners, if you ask them, their biggest complaint would be that they get brought into the process too late. That the product's already designed and it's given to them to test it and give a stamp of approval. And by then it's too late, right? Because you've invested too much time in going down the wrong path. So what we try to do and the way we approach human factors is address it from the very beginning, and you'll kind of see that as we go through the talk today. Just to round up me, I have kind of been on both sides of I'm in consulting now, but I started off my career in your seats working in industry. So I cut my teeth at Fiskars, which most people know for the orange handled scissors. Great company for somebody that likes ergonomics and human factors, because that's kind of what they built their reputation. And more recently, Dave and I actually co-teach a course in product design through UW-Madison that's offered through the mechanical engineering department, but cross-listed with other departments. We have business students in there. We have some art students from other different engineering disciplines. So it's been really fun to keep our ties really close with UW. Great place, great resource for us as a company and for me personally. After we're done, there's going to be lots of opportunities for mingling. I want to encourage you to also feel free to talk to Amrish and Kurt, two of my colleagues from the Human Factors Department. So feel free to kind of pick any of our brains if you want to talk more about any of the stuff that we talked about tonight. Okay, so in all honesty, I don't know where you guys stand with what you know about human factors and ergonomics, right? Some of you might already know a lot of this, and hopefully there will still be some things that we'll be showing you that are new, or that are new twists that you haven't seen. But I've kind of tailored this assuming that you might not know anything about human factors, right? So I'm going to try to cover like a broad range of topics, give you kind of exposure to the discipline, give you an understanding of what we do and how we do what we do, and in the end, kind of wrap it up with a little case study that shows a lot of this in practice. So hopefully that'll kind of bring it home. So first of all, human factors and ergonomics are kind of synonymous terms, right? Personally, as a profession, I prefer the term human factors because ergonomics has been kind of made into a buzzword or just kind of an adjective. A lot of people say ergonomic when what they are really talking about is something that's comfortable. And comfort is part of the story, but if you look at the etymology of the word ergonomics, it really comes down to the fact that this is a study, right? So this is a scientific endeavor that's based in testing, based in empirical facts. And the really neat thing about ergonomics and human factors is if there's a benefit, it should be measurable. This isn't just somebody saying, I like this one because it's blue. We should be able to draw back to what the true benefits are to that person. So you'll see I kind of use ergonomics and human factors kind of interchangeably throughout the talk here today. One way that I like to describe it is you can kind of look at ergonomics from the neck up and from the neck down. From the neck down, it starts with an understanding of our body, our anatomy, our body structure, our physiology, how our different body systems work together, and biomechanics, which is applying engineering principles to physiology so that you can use it as a predictive tool of what people are capable of. From the neck up, it's much more about cognition and thought processing. So again, starting with our senses, our body, how our senses take in stimuli, and an understanding of how our brains are hardwired to react to stimuli in a certain way, so that we can manipulate that to our advantage. Manipulate's a bad word, but use that to our advantage to present information, whether it's digital information on a screen, or contextual cues on a physical product, that help communicate to the person in a way that they're going to detect, receive, and understand and act accordingly. Okay? So what we try to do is blend both the mind and the body, that sounds kind of zen, and really look at the complete use experience of different products. Perhaps a better definition of what human factors and ergonomics is all about is the study of the interaction between human beings, the tools that they use, the tasks that they do with those tools, and the environments that they do. Okay? So just as way of an example, this is a mandolin slicer. Anybody ever used one of those? Okay, great. Anybody else cut part of their thumb off? Okay. Human factors person, I guess, is always the first person to go to the ER. So if we look at this in the context of this example, the person that's using that might have a really different experience than somebody else, based on their body makeup, based on how tall they are, based on their gender, based on their age, maybe based on their training and previous experience. So how a product presents itself might remind them of other products that they have. They might just kind of fall back on some known muscle memory and assume that this product is used the way they think it is, right? So one of the things we look at is the person that's going to be using it. And in general, the more specific that you can get about who your target user is, the better the benefits that you can get. You can really kind of dial it into that person as soon as you start learning specifically about who's using it. The toughest thing to do in the world is to make a product that's used by everybody and does a whole bunch of things, right? Because it just leaves it open to a lot of different circumstances that you all have to take into account for. And design's all about trade-offs. And the broader that gets, kind of the more you have to average out a lot of the features that you're looking at. Second thing that we look at is the product itself. And this is the thing that's easiest for people to jump onto, right? And to recognize, oh, this one has a handle that's kind of perpendicular. This other one might have a handle that's more in line with it, right? So if you just look at this, you could work yourself into a corner and be going down the wrong path. You have to take that into consideration with everything else we're talking about. But as product designers, this is the first thing that everybody is kind of taught about, like how to build these features and what those features could do. The other thing that we look at, which is perhaps most overlooked, is the actual task that's being done with that product. So in this case, we found something really interesting. If you use a mandolin slicer to cut through something like a cucumber that has a real thin skin and a nice watery part, it's really quick and easy to cut through. And people were actually orienting the product differently. They kind of put it perpendicular to themselves so they could use this quick elbow motion to go through real quick, fine cuts, right? If you're doing, making French fries with a mandolin slicer, it's completely different. That potato is really hard and starchy and thick to cut through, right? You're making thicker cuts. And what people did was they actually kind of oriented it differently away from them so they could do this type of a pushing motion. Sorry for those of you that are joining us by the web conference. But you're pushing more away from you because that's a motion that you can do with more strength. You can get more of your arm behind it. So if you didn't understand that task part, you could go off designing a handle with a particular handle that might not be matched to how people are orienting that product for the task that they're doing. Okay? And ultimately, a lot of this comes down to grip architecture, which is kind of an interesting thing and something that I'm kind of passionate about. And grip architecture is nothing more than how you grab products with your hands and how you manipulate them. Okay? So think of it this way. If you go to your knife block in your kitchen, right? Stuck in culinary example. You'll have everything from a big chef knife to a little paring knife, right? But somewhere in the middle, there's that kind of utility knife that's kind of the catch-all, right? And you can use that utility knife to cut everything from thin slices of bell peppers to cutting through carrots. But if you're really conscious, if you go and look at how you're holding that knife the next time you do that, you assume a completely different grip architecture. When you're cutting through carrots, again, it's a hard thing to cut through. You're kind of grabbing with what we call a power grip, and you're exerting a lot of force down on it. When you're cutting bell peppers, it's much more delicate. You're trying to get thin slices. And you adopt a grip where your index finger, middle finger, and thumb are much closer to the business end of the knife. So you can have really fine control as you're making thin, delicate slices. Okay? So ultimately, it comes down to the amount of force and control that you need. That dictates how you hold things, how you grasp things, and interact with them. The interesting thing is most of us do that on a completely subconscious level. We're not thinking, I'm going to cut through a carrot, I better hold it this way. You just naturally, through the process of doing that task, figure out the way you need to hold something. And I really believe it starts when we're little toddlers dropping our sippy cup. We go through life building this feedback loop of, I dropped it, I've got to hold it a different way. Think of the last time you moved from office to office or home to apartment or something. You pick up a box and immediately you reposition based on the load of it and the balance of it, right? You look at a box, pick it up one way, but you shift without thinking about it. So this whole idea of grip architecture and the whole idea of task is something that we spend a lot of time looking at and understand what that task is that they're doing and what the requirements are in terms of physical exertions to make that shape, to make that form that they're interacting with most appropriate. The last thing is that we look at is the environment. And the environment, too, can have a big effect on how you use products. So in this case, this person is cutting at a kitchen counter height and onto a paper towel. We also saw in the course of this research some people that were sitting down at their kitchen table. We saw people that were cutting into bowls instead of onto a flat surface. And all of this changes your induced posture. Sometimes we're using a product and we're free to adopt whatever posture we want in space and do the task and exert the force and control that we need. Other times, because of the environment, we're kind of forced into a posture. And that's where a lot of problems can come up. And in fact, that's kind of where the whole field of human factors and ergonomics grew out of, right? If you trace us back to our roots, it kind of came from industrial accidents. And manufacturers were trying to find something that prevented their workers from getting hurt, not necessarily out of a real kindness for the worker, as cruel as that seems, but really because it was hurting productivity. And in the early stages of industrialization, productivity was king, right? So we had to fix that problem so the person didn't get hurt, so that the production line could keep going. You know, now I'd like to think we have a much more enlightened approach to that, and we're trying to do things for the right reasons. But a lot of these problems can come from the posture that you have to induce in the environment to do what you want to do with the product you're using. Make sense? Okay, so the important thing that comes out of this whole thing is you really can't think of a product as being inherently ergonomic. There is no UL stamp of approval for human factors the way there is for electrical appliances that get plugged into a wall. And it's because you have to take all four of these things into consideration. You can have something that's perfectly designed for a particular environment, put it in a new environment, and it falls flat on its face. Okay? And the poster child for that, for me, is this OXO peeler, right? And not slamming OXO. I own a lot of OXO products. But in the early 90s, when OXO was introducing their good grips, the first thing they introduced was this peeler, right? And if you believe the story on their website, you know, there is a lot of research and a lot of iteration that came to this peeler that the inventor was making for his wife who had arthritis, right? So even if that was good and appropriate work and there's good sound rationale behind the design of this, that doesn't necessarily mean that that same handle should be put on all of these different tools. And that's exactly what OXO did early on. They're like, we've got a great peeler. What else can we sell in the kitchen that we can stick this on? And they literally stuck it on everything, right? And if you go back to what I was talking about in terms of grip architecture, just think about the way that you hold these things, right? So this is a knife. Again, you could be making delicate slices. This is something that you smash up potatoes with, right? Really, really different ways you interact with that device and really different things that you're trying to do with it. So this is great from a branding perspective, but potentially horrible from a usability perspective, right? So we have to take into account for each one of these things, again, what the task really is, what the environment really is, and make a determination on whether or not that's the right handle for that particular application. So that's probably one of the big things I'm hoping you'll take away from tonight, is this idea that you have to keep all four of those things kind of in the forefront of your mind, and that there really is no ergonomic product unto itself, okay? So another thing that we try to do from a human factors perspective is really our role in the design process is to try to dial into the design as best we can to fit the capabilities, limitations, and needs of the people that are going to be using it. So if you break that down, if we're talking about capabilities, that's all about fitting the user, right? So we recognize, again, that there's big variations between different types of users. So again, trying to understand how that variation among the people that might be using it will affect the design. When it comes to limitations, that's all about preventing injury, right? That's going back to the early roots of not getting people hurt in the process of doing what they want to do. And when it comes to needs, that eventually boils down, in terms of human factors, to improving usability and efficiency. And we're going to talk about each one of these kind of in a little bit more detail. But before we do that, I just kind of want to show you a little bit this diagram that kind of blends in how all the disciplines, and this is only a few disciplines, right, within that make up product design, but that there's a lot of overlap here. And each one of these disciplines has something that they are perhaps uniquely qualified to take the lead on. But there's a lot of overlap as well. So in terms of human factors, that really boils down to kind of this usability, that we have specific tools and methodologies that are really meant to approach that. But that also means that, you know, we have something to contribute in terms of the form factor in those touch points and interactions, right? There are other things in terms of form and function that the person might not interact with as much, right? So think of like a casing for an electronics box that would sit on your desktop or something. There might not be physical interaction with that, so there's probably less of a role for the human factors person. And again, when you're looking at the crossover between human factors and engineering, a lot of it comes down to the understanding of that workflow. What type of performance has to happen at what time, and how do we set up that experience, and how do we make sure that the guts of the product is supporting that and supplying what it needs, what the user needs to see. So there's a lot of cross-pollination, but in the end, we're all responsible for defining and improving that user experience. We all just kind of come at it from a different perspective. Make sense so far? Okay. So let's dig into these three different things: capabilities, limitations, and needs. So in terms of capabilities, there's a lot of different tools that we have that we can kind of tap into to get up the learning curve and understand what capabilities of a person is for this particular application. One of the things we do a lot of times from the very beginning is do a literature search to keep ourselves from reinventing the wheel. So this is not necessarily what you do for like a typical consumer web search. This is kind of scouring academic, scientific publishing databases and coming up with what are sometimes really, really dry articles that you have to read that are research publications of what people did and what they learned and how that might apply to the task at hand. So in this case, you might be looking for cleaning tools, and you can find a variety of different articles on what the effect of that shaft shape was on the task that they were doing, whether it's raking or shoveling or mopping. Okay, so again, get up the learning curve as quickly as possible, learn what's already known in that domain, in that subject matter. For better or worse, one of the things that a lot of people associate with human factors and ergonomics is anthropometry, which is kind of the study of body sizing. Just about everything about our bodies has been kind of measured and cataloged, and a lot of that information is available to us through different databases. This is one that actually came from the military, and it's kind of an interesting thing. A lot of the early anthropometric databases came from military sources, and I guess it kind of makes sense if you think about it. Back in the day, when you went into battle, you might go in with the sword that was handed down by your father, or a sword that was made specifically to you, right? As standing armies grew and you were no longer providing your own weapons of war, the government had to provide those for you, right? So A, they have a captive audience, right? So they can measure you and make sure that it's going to fit their particular population. And two, they have a vested interest to make sure that everybody can fit in their tank and that everybody is properly outfitted with clothing and gear, right? So there are a lot of great military databases. So just about any physical dimension, you can often find some measurements, and these are broken down in terms of percentiles. And again, I'm probably 99th percentile height, which means that I'm taller than 99% of the population, right? But there's an interesting thing about using this data. You have to use it the correct way. I think there's a big misconception. Often in design, you hear that you're trying to accommodate the 5th percentile female and the 95th percentile male. And the idea there is if you're looking at a 95th percentile male, they're a pretty tall person, and if it can work for them, that's great. And if on the other side you're worried about the shorter females, right? And can they reach everything? Can they manipulate everything that they need to? And if you can cover those two extremes, you're probably covering a good chunk of the population. You might not be able to accommodate everybody, but you can get a lot of people within those two bookends. The trouble is there's no such thing as the 95th percentile male, right? So there isn't a person that has 95th percentile height and a 95th percentile reach and a 95th percentile index finger length, right? So going back to our idea of the task, what you really want to do is use data that's particular to what you're trying to size it. So if you're really trying to see if somebody can reach something, you don't care about their 95th percentile stature. You're looking at the data for that reach. Okay? So it's powerful data, often used incorrectly, but it can really help you kind of sculpt the space envelope that you're working around. There's been a lot of other publications that come out, not military sources, but civilian sources as well. And there's a lot of, as you can see in this one, there's a lot from different countries. It's all being used for you. So again, a great database in today's kind of global economy. You don't have to rely on just US data to design products that'll fit a global market. Sometimes those measurements have been kind of collated already into design guidelines and design requirements. So somebody has already done a lot of the work that if you size this knob for this particular function to this size, it's already going to be usable. Somebody's already done the work for you. A lot of times you can find great resources for this that get you kind of on the starting path. But again, because you have to dial it in with all those four fields of user, task, environment, and tool, this is just a starting point. That's your launching point. Sometimes, if you don't have that information, if you can't find it in resources, you can collect it yourself. So this is some work that Kurt and I did some years ago with Harley Davidson, and we did an anthropometric study at a hog rally in Milwaukee. So we had a tent set up, and people would just come as they were waiting for their test drives, we take some standard measurements so we could compare them to the published data. We take some very specific measurements. So we couldn't find, for instance, any data that related directly to how far people can reach to pull their brake and clutch levers, right? But it's really easy to make a fixture where you can have them assume that posture and see how far they can reach. Similarly, we did strength measurement too. This is a grip dynamometer where you squeeze really hard and it gives you a static measurement of how strong you are. So part of the reason for doing this was to see if that kind of stereotype of Harley riders being big, strong, burly people was true. In a lot of cases, it wasn't. We probably processed 400 or 500 people over the course of this weekend. So we had a great data set that we could compare to the published data. And it's an interesting thing because trends are changing. There's a lot more white-collar upper executives that are riding Harleys now. So some of those stereotypes just don't ring true. So if you tried to design something assuming that was going to be a big, burly person riding it, A, it might not be that person that's riding it, and two, it might really limit what markets you can get into and what you can sell based on people that have different body sizes. So that's ways of collecting some of that data. We can take it even a step further. We have some really fun resources here from a practitioner point of view that kind of make me happy. So a lot of times we're making prototypes with embedded sensors in with the help of our electrical engineering and our model shop, where we can have people actually performing a task and be collecting data in real time. And one thing that we do is while we're taking those measurements, we'll also measure some standard things. And there's an interesting kind of statistical trick you can do. If you can find a correlation between these standard measurements and the specific measurement that you're taking, you can keep yourself from having to do this type of custom testing on a ton of people. If you find that correlation, you can apply that to a published data set and calculate out a predicted value for what a larger population would give for your particular application. So there's some little tricks of the trade. I don't want you to think that ergonomics and human factors is all about conducting big, huge studies with a lot of people. A lot of what we do at Design Concepts is taking a much more pragmatic approach to it and finding ways to get the answer that we need, or at least 70 to 80% of the answer, so that we have more confidence that we're going down the right path. So the work that we do is on a much accelerated scale compared to a lot of our colleagues that might spend a year or two doing something in academia. And I think that's perhaps one of the things that I've heard a lot is there's a perception that human factors means big protracted studies and it's going to be really expensive and really time consuming, and it doesn't have to be. Okay, so let's talk real quickly on the other side of limitations, right? So that was all about making sure that we have an understanding of the people that are using it so we can design it and tailor it to them. When it comes to limitations, it's much more about trying to prevent injuries, right? And there's a different type of injury that we're talking about. Most people are used to acute injuries, which is you slip and fall and break your ankle, right? You can trace it back to a causative event that gave you that injury, that disability. What we often talk about in human factors and ergonomics are cumulative trauma disorders, which are kind of micro injuries. They're usually to your soft tissue, and any one of those isn't debilitating. But over time, it kind of grows until the point that it is debilitating, okay? So these can slip under the radar much easier than acute injuries because you can't trace it back to that one causative event. It's a whole lot of things that you did over the span of time that gave you this particular injury. And we know from research that there's 6 different risk factors that contribute to these type of injuries. For the interest of time, I'm not going to go through what each of those are and why they mess up your body, but let me just say that it all kind of can be blown up, and we can do a lot of stuff. Our bodies are amazingly designed, but we always kind of push ourselves to do things that are kind of outside the realms of what's normal or expected, right? So just because you can adopt some weird posture and get something done, that doesn't mean you should be doing that a lot or over and over again, right? So when you do that, when you kind of violate these different risk factors, you're making yourself more prone to injury. Some of these types of injuries, there's different ways of preventing them. Again, so we have design guidelines. There's been a lot of research done that can help give you guidance on what's good and what's not. Again, based on, look, this is for different handle types, right? And again, it comes down to the environment and that orientation and what you're doing with it, right? So sometimes it's in the form of great guidelines, and sometimes you have to kind of learn about it yourself. So there's There's different ways we can do this on kind of more the high-tech end of the scale. One thing we can do if we're looking at extreme postures is use what's called goniometers. It's basically a sensor that you put one part across each joint, and as you're moving, as you're working, it's recording data in real time, showing you whether you're putting yourself in postures that are outside of that range that is safe to stay within. There's other ways of doing this. There's kind of the flock of birds approach that you might have seen in the making of movies where you wear the suits with the little ping pong balls on, and you can do a lot of mapping. Rich source of data. It's often best done if it's a really, really repeatable task. If you're doing something really, really dynamic, this isn't necessarily the best thing. It just produces a ton of data. Another thing that we can use, another tool in our tool belt, is EMG, electromyography. Basically, this is a way of looking at how hard your muscles are working. So think of it this way. Every contraction that happens from our muscle is triggered by an electrical impulse from our nervous system, right? And one of those impulses goes and triggers what's called a motor unit. It's a bunch of fibers that contract together. And the stronger of a contraction you need to make, the more impulses go and the more of those motor units fire at the same time. What we're effectively doing with EMG is we're trying to measure how much electrical activity there is going to that muscle. So we put surface electrodes on a person, and it's basically measuring that residual electricity. And so you get, as you move, you get traces that look like this jagged line. You can smooth out and rectify it, and the area under that curve is an indication of how hard that particular muscle is working. So the bigger the amplitude, the longer the time, the more exertion that's going on there, okay? So that's one way of looking specifically at muscle groups that you know are either used or prone to injury or damage. If you're looking at a whole body solution, this heart rate is a great thing to use. So you can use the same type of equipment that triathletes use in their training, right? Not very invasive at all. You're wearing a chest piece that communicates to a wrist unit. Again, this is kind of what that data looks like. And the amplitude, again, is how hard your heart is beating. So again, from a full body expenditure, the more you're moving, the more your heart's pumping out oxygenated blood, right? So the area under that curve is a great reflection of how much of a whole body exertion is being done. So there's ways of testing your product, ways of looking at what you're doing with that task so that you have evidence and data, again, to convince yourself that you're on a safe path and that you're doing something that isn't going to lead to injury based on the limitations of people. Moving on to needs. I'm sorry, I'm kind of cruising through this at a good clip. We do field research to try to uncover user needs. And there's kind of two different things you can look at. So, and again, most of the research that we do is in the field. We don't tend to bring people into a conference room like a focus group. Somebody's working in their garden, we want to see them working in their garden. If they're cleaning toilets in an office building, we want to be there at 3 in the morning when they're cleaning toilets, right? Because there's rich contextual information. Sometimes those people can tell you the blatant needs. They know when something's wrong. They're more than happy to tell you about it in hopes that you can fix it. What we really are looking for when we're going out, it kind of works hand in hand with that, is these latent needs. Okay, so these are things that you can only really uncover through observational research, by being there and seeing what people are really doing. And most of the time, people are completely unaware of these problems. It's just business as usual for them. It's the way it's always been done. It's like if I asked you right now, when you tied your shoes, which shoelace did you start with? You probably don't know, right? You don't give it any thought. And that's what these latent needs are. We go in kind of knowing what to expect or knowing how the process is supposed to unfold, and we're able to observe what people are really doing, the type of workarounds that they've come up with to manage the fact that what they're using to do this product with doesn't work with. And sometimes you see evidence of them modifying what they use just to make it easier for themselves. But again, they might not necessarily volunteer that as a problem because they've already come up with a solution. It's not really on their radar anymore as a problem. So again, we try to pair both of those together. We like to talk to people, but a lot of times from a human factors perspective, when we're doing research, we want to be kind of a fly on the wall. We want to not interrupt them, not interject with questions, but let them do their entire process of what they're doing so that we have a good record. And a lot of times we're videotaping that so we can go back and pour over that and over that. So when we go out into research, we're observing behavior, right? And we send teams out into the field that are comprised of of human factors people, industrial designers, engineers, research and design strategists. All of us go in with a different set of training, a different perspective. We take different things away from that engagement with users. From a human factors perspective, what we're looking at once we observe that behavior is what's causing it? What's the underpinnings of that? Is that something that's cognitive, that neck up, or is it something that's physical from the neck down? And how many of those things are good and beneficial, and we make sure we're retaining those so we're not introducing the next generation of something that takes away something that people really like. But even more interestingly, what can we manipulate to make bad behavior a little bit more palatable? One of the toughest things to do is to change behavior. But sometimes there's things that you can subtly do to encourage people to do it in the right way that you intended. This is especially true if you're introducing a product in a mature category where there's already things out in the field. Again, people have that muscle memory. People fall back upon their bad habits. So when we're changing behavior, a lot of times the only thing we can do is make the way that they interact with things conventionally not even an option. You have to make large changes if you're really going to make behavior. But there are also some subtle things that you can do to kind of improve the way that people are working with things. So again, those are our 4 levers that we can adjust. We might make something that, there were a lot of people that were using it. Maybe some of those people shouldn't be using it. Maybe it should be just for qualified people. There's a lot of things that we can do to the tool. There's a lot of the things efficiency-wise that we can do the task. And the environment thing is more often something that we don't have control over necessarily unless we can kind of completely change the way people have their work area set up. So one of the ways this kind of manifests itself, these findings, when we're trying to translate these into user needs that are going to drive the conceptualization process, one way is to make what's called a workflow map. And for those of you that are here in the room, there's a bigger version of this. You clearly can't read this on the screen. But this is a typical procedure in the operating room. And each of those colors is a different person. One color is a nurse, one color is a doctor, one color is a tech, one color is a patient. And from this, we can point out pain points, problems in this whole process that are ripe opportunities for improvement. One of the things that's interesting about a map like this, we've found over and over that when we talk with our clients, a lot of them are domain experts within one portion of it. But a lot of people don't get to see everything beyond their area of expertise. So when you finally put it all in one map in one place, it's kind of an aha moment for a lot of people. They're like, I never really knew that happened for this product, or that person had that particular interaction. Another way we sometimes map this out is with what's called a swim lane diagram. So in this case, each of the rows is a different stakeholder, and any of the boxes that fall in that row are tasks that person is uniquely qualified for or taking the reins of. And the kind of winding arrow leads you kind of through the process as time progresses from left to right. So this particular swim lane diagram is a map of how the human factors process is applied to the way the FDA wants medical devices to design. So, and that one's over here on this wall. If you're interested in mingling afterwards, you can take a closer look at this. Ultimately, a lot of this information gets kind of boiled down into design specifications as well. And this is kind of the first step, because once you have an understanding of this workflow, we can do an analysis of each one of those tasks and look at that particular point of the task. What do people have to take in from their senses? What do they have to understand? What type of processing? What do they have to think through? What decisions do they have to make? And ultimately, what type of actions do they have to take to perform that part of the task? And we look for things, all of the things that can go wrong while they're doing that task, and try to design that out. So lastly, let me go through a real quick,
I have a web question related to that.
Okay.
How do human factors and user research overlap and interact?
So, a lot. We use a lot of the similar tools and methodologies. A lot of what we do is based in ethnographic research, which again is going out into the field. A lot of it depends kind of on what your goal is for doing the research, right? So you can think of research being done either strategically or tactically. So a lot of times when you're doing strategic research, you're going out in the field to really understand what the opportunities are within that market. and you find behavior, you find problems, and you're trying to understand if we make a product that addresses that issue better, what does that mean to the company? What does that mean in terms of market share? What does that mean in terms of the brand of the company? And is there a real business case that justifies the company going through the expenditure of making a product to address that? Okay. And at the same time, you can be doing research in the field that's a little bit more tactically based, right? So if we're going to make that, what specifically do we need to learn and understand that's going to drive the specifications that we're going to be designing around? And the specifications kind of lay out, from a performance point of view, what actually has to be done by that product for it to be successful. So there's a lot that the two types of research have in common, and a lot of times, so again, we have human factors people that do research, we have design strategists and business strategists that do research. Sometimes we're working together, sometimes we're one of us is taking the lead and the other is having a secondary role. So a lot of it kind of comes down to what you're trying to do at any particular time in the process. Before we go into the case study, any other questions about what we've covered so far, what we've talked through? No? Okay, I promise you I'll get you back to cheese and beer soon. So let me just kind of walk through this real quick, because it's a product that I have a lot of love for. I think we did a great job in this, and actually, if I can say that, it was kind of fun. So we won the Human-Centered Design Award from the Human Factors and Ergonomics Society. So that's our professional organization. It's the closest we come to an Oscars for human factors. There's not a ton of human factors awards out there, right? And it was really funny because when we received the award and made a presentation, the president of HFES was there, and he was like, "This is so cool. I would have expected this type of work to be done if this was a medical device, right? This is a floor finish applicator, but it just kind of underscores how much you can really dial in some benefits for everybody for what they need." So this is the product that came out on the market. We have an example here. So this is by Diversey. At the time, they were actually Johnson Diversey. They've had another name change, but Diversey was always a chemical company. So they made a lot of the finish for floors. They never had their own applicator. So this was going to be their first foray into doing a floor finish applicator. And basically the way it works, there's a little reservoir of floor finish that's carried on the pole. And every time you squeeze that trigger, it opens up a pinch valve at the bottom and just dispenses a little puddle right in front of the head of the mop, so you can kind of smooth it in. It's basically meant to replace a traditional mop and bucket. And if you haven't seen this done, you basically start by pouring a whole bunch of finish into a bucket from a bulk storage container. If you guess wrong how much you need, and you go over, you end up dumping it because it starts to harden with exposure to air, right? If you don't put enough in, you have to go back to the supply closet and load it up again. So that part alone is kind of a pain. But basically, you kind of dunk it in, wring it out to the right consistency, and then apply finish to like a little 3x3 area and keep replicating that 3x3 area until you get across the whole floor. At the end, when you're done, again, you have to dump out everything, rinse out your mop to make sure that it doesn't harden, because again, once it gets crusty, you have to throw it away. So basically, there were a lot of known problems with this, and a lot of it are on the side of waste. Wasted water to clean things out, wasted finish. But the interesting thing is there's a lot of people in a crew that would work in building maintenance, right? But there's generally only one person that does the floor finish application, because it's something that you really have to go outside for training to learn to do well. And if you don't do it well, you're going to have to strip it down and reapply it anyway, and your floor is going to look horrible, right? And for whatever reason, the one person in every crew that ends up doing that is always the oldest guy. That's the person that's taxed with that job, right? So it is a physically demanding effort. So, you know, we did a literature search, and we found that there were some problems, and we knew what kind of injuries you're likely to happen if you're using this type of stick handle tool. So Diversey came to us already with kind of the nugget of the idea. They wanted to have this juice on board. They wanted to have that reservoir on the pole so you didn't have to keep going back to the bucket, so it could be more efficient. And in particular, they're kind of targeting smaller areas. So think of like small retail spaces. Think of hospitals and schools where you might have a small room and you might have a small window of opportunity where you can get in there, and lay a finish before the next patient comes into that room. And the biggest thing that they wanted to do is make sure that everybody on the crew could lay down a good coat of finish without having to go out for training. So open it up to everybody instead of just that one old guy that's there, okay? So we started out, as I kind of alluded to, by getting up that learning curve really quickly. So one thing that we did is some immersion. We learned how to use, our design team learned how to use the different tools that are out there. A conventional mop and bucket. There are other applicators out there. If you look at that, that's a pretty good idea, right? If you're carrying the reservoir in a backpack that's close to your body, right, so you don't feel that as much, you can carry a lot of things on your back, a lot of weight before it starts to bother you. And it's kind of tethered to a pole that had kind of a release system. There's actually some problems with that, because if you have to move a chair or a table in a school, you actually have to take that off and put it away before you can move it and put it back on. So kind of a nugget of a good idea, but maybe not the best implementation of it. The other thing that we did is we went out into the field and looked at how people were using it within these market categories, right? So this is what the janitorial closet looks like of a hospital or of a school compared to the back room of a retail space, right? So we had to keep in mind that entire life cycle of where it starts, where they use it, and where it finishes up. And what we did is we actually went out and again, observed these people doing what they do. The beauty of this type of research is that you don't have to have a huge sample size. As a rule of thumb for human factors, 80% of the usability issues are going to be identified by the first 5 to 8 representative users, right? So we're able to use relatively small sample sizes, make sure that we have all of the markets covered that we want to look at. We're going to talk specifically about this person on the left. That's a professionally trained person. He went out and learned how to do a good coat of finish, versus the guy in retail that you can see he's kind of like swabbing the deck, right? So the real way you're doing this, you're supposed to make a U and then kind of make figure eights as you work backwards through that 3x3 square. Our self-trained person just kind of read the back of the bottle and tried to go at it himself. And you can kind of tell the difference in the quality of the floors, right? The nice white floor, the dingy floor. It's the same VCT, it's the same vinyl tile. So we had a lot of learnings while we were out there. So we did a lot of work internally. We had, again, industrial designers, mechanical engineers, and human factors people doing 2D and 3D brainstorming. We found that Conduit was a great surrogate for stick tools. It's really easy to work with, really easy to bend. And we learned from our literature search that there's some interesting effects that you can get by bending long-handled shafts, and can have some benefits to the people that are using it. So we went out in the field with some really, really low fidelity mock-ups and prototypes. And this is kind of called an approach called participatory design. So the first thing we did, and these are examples of them, you can play with them after, but we took a straight handle and put Velcro on it and filled this reservoir with water and let them play around with it by when you move that reservoir to different places and see how it affects their control. So what we generally found is the lower that reservoir is on the shaft, the more you feel it in your lower back, because it's a big weight that's far away from you. The higher up it is, the more you're carrying that load in your arms and shoulders, and the more free-flowing the head is. Okay, so we gave people a chance to experiment with that and get a feel for where they liked it along the length of that shaft. Then we introduced some shafts with different shapes, everything from just a single bend to a curved bend to a kind of a funky auger. And we had done a lot of experimentation. By this time, we had probably made some 50 or 60 different handles, all with bends in different places, different amounts of bends, and really had a good understanding of what each of those bends does from a performance point of view. We also included some really low fidelity mock-ups of different controls, right? So these aren't capable of dispensing any floor finish yet, but we gave them the opportunity to simulate that, right? So we could quickly snap these on anywhere on the top, in the middle, whether you're using your left hand or right hand, and a lot of different types of actuators. And we basically gave everybody those pieces and let them mix and match and experiment until they came up with what they liked. So our professionally trained person liked this approach with the bent and curved handles and that reservoir up really high, because he could whip the head around and get into places where he could never get into with his mop and bucket. He just loved the control of that and had enough brawn to handle the weight being up really high. Interestingly enough, when you gave that same type of configuration to the self-taught person, he was still falling back on his old habits. He was swabbing the deck. But an interesting thing happened when they started using this auger-shaped handle without any instructions. And again, we introduced these to them in a randomized order so that, they could try whatever and we weren't biasing them. But immediately with that auger, his posture completely changed. He was upright and he started cutting figure eights just like you do when you're professionally trained. So this is kind of an aha moment, that silver bullet, when we realize there's something to that shape that intuitively communicates how you're supposed to interact and that this is for cutting circles. So this was, again, kind of one of the big direction-setting moments within the program. We could have designed a product that would have been great for the people that are already doing this, right? But what they were really going after was making sure that everybody on the crew can cut those figure eights and apply a good coat of finish. So we intentionally went down that path, and we went through a development program looking at different nuanced ways that we could address each of those features, from the actuator to, how much of a bend, whether it's a curved bend, a straight bend, all kinds of different variation. We have those models here as well. Again, these models don't dispense any floor finish either, but we went back out in the field and let people try these out. We went back to each of these individual environments again and let people go through a simulated use of this. And before we let them try one, we gave them a questionnaire. And this questionnaire asked them to rate the importance of all of these different features and attributes of this floor finish applicator, which they haven't seen it, just based on their experience. So how important is each one of those to you if you were in a position to make a decision about this? Then we let them use it one by one, introduce them in a random order again, and after they used each particular one, we had them fill out a satisfaction questionnaire. Same list of features and attributes, but this time we were asking them to rate how satisfied they were with the way that particular concept dealt with each of those features or attributes, independent of how important it is. Like, how well did this perform? When you map those against each other, you get what's called an importance and satisfaction map. And there's 4 quadrants, right? So things that are in the blue quadrant are things that are really important to them, and they're really satisfied with it. Great, that's where you want to be. Leave it alone. Don't put any more design resources into improving that, because you're just going to drive it further into the blue. If it's here in the red quadrant, though, or orange quadrant, whatever you want to call it, that's something that's really important, but they're not satisfied with it. That's where you want to put your design resources to make those features better and drive them into that blue quadrant. If they're in the green quadrant, it's something that's not important to them, but they love it. Great. Again, leave it alone. There's no point in doing that. You're not going to make that more important to them by making it better. And if it's something in the yellow quadrant, it's not very important to them, and they kind of think it sucks. So maybe drop that feature altogether, right? What's the point of spending the money on that feature? So there's a lot of different ways that you can deal with this data. You can look at it in aggregate. You could break it down by professionally trained versus self-taught. You can break it down by hospitals versus schools versus retail. But in general, just flipping through these, you can get a kind of sense of the migration patterns from feature to feature and how relatively successful each one of those is. So we did analysis of this data and came up with a particular feature set that seemed to be the most promising elements of each one of those concepts. So this is a great tool because even if somebody did not like this particular prototype in general, they might have really liked this trigger. And we're able to kind of tease out that information without people getting stuck on the, yeah, but I didn't like that applicator. Okay, so it's a great way of making sure that, again, you're saving the things that have value, and that's going to fall. Yes! It's amazing that it took that long for all of them to fall down. I don't want to kick these just to be complete. Okay, so, and just to prove that when you do that, when you recombine those things, that the sum is greater than the parts, we went back out. We conducted that research, and we did find that this particular combination drove all those features and attributes into the quadrants that we wanted to be. So we were pretty confident that we were heading down the right path with this design. You know, it had that stamp of user validation. One thing that we wanted to make sure, again, because we did a literature search that proved that there's potential problems with these stick tools. And since diversity was new to floor finish applicators, right? Great reputation for floor finish, but why should anybody believe their floor finish applicator is different, especially if it looks a little funky with this auger shape? And basically to prove, too, that we weren't fixing one problem and creating another problem, we did a quick pilot study of the physiological impact that this new design would have on the user. So we took 6 different users. All of them had experience in a conventional mop and bucket, but hadn't tried any other applicator. And we put our new design up against 3 other applicators. So that backpack that you saw before. And this flat mop is actually one that's used in Europe and Asia a lot. A little bit different technique. So they were all taught in how to apply with this new type of applicator and given time to practice. And we use the exact tools that we were talking about earlier, right? So one of the reasons why they're all wearing the same clothes is, well, not really, but under the Under Armour shirt is there to keep all the surface electrodes down for the EMG, and they had a battery pack that was communicating to our wireless. They also had heart rate monitors on. If you see, they're all wearing the same watch. So these are the muscles that we studied in EMG because we knew these are the ones that were heavily used in the task and susceptible to injury. And if you squint your eye, you can look that both the mop and bucket and the flat mop take a lot more effort than the backpack and the Pro Speed, right? The distribution between those is a little bit different based on how that particular applicator is used. But this is a great sign, right? This is achieving what we want. It's an improvement in terms of the muscle use compared to what people are conventionally using. Again, if you look at it from a heart rate perspective, from that whole body exertion point of view, again, the mop and bucket and the flat mop take a lot more effort, a lot more exertion. And if you squint your eyes again, the backpack and the Pro Speed are about on even par. The one thing that's really, really interesting about this, though, is the breakup of tasks. Because we are collecting data from the very beginning to the very end, we found that getting the backpack set up took a lot more effort because you have to fill that reservoir, manipulate it in the backpack. There's a lot more whole body effort compared to taking this reservoir and just simply dropping it into the holder that's already, yeah, that's going to go too, that's already on the shaft. And similarly with the cleanup, this is a disposable, recyclable outside. So you throw away the cardboard, pitch a small plastic reservoir that's on the inside. As opposed to with the backpack unit, you still have to rinse that out just as you do with a mop and bucket. So again, the extra effort that you have to put into set up and clean up is kind of offsetting the gains that you're seeing while applying the finish. So this was a great story that Diversity took and rolled out at their trade show when they introduced this. And people were kind of amazed. They're like, you mean those aren't made up marketing numbers? Those are like real scientific evidence of what's going on. So again, it did kind of 2 things. One, it was a great selling point as they were introducing their product. But 2, it gave all of us on the design team the confidence that we did have a successful product and that we were meeting all of our, achieving all of our goals. Again, not creating new problems for people in the process of solving an old problem. Okay, so that's it. Sorry, I ran a little bit long. Let's open it up to questions. I see there's one more question from Webb.
Yeah. Where does emotional reaction fit? This is different from perceptual reactions, but equally, if not more important.
Yeah, you bet. And that's something that, so even as we did this study, one of the things we often do is administer questionnaires along the way too. Because it's a really interesting thing. A lot of what we're talking about is about analyzing the performance of people, how people are interacting with these products in real measurable ways. But there is that emotional element too. And people's likes and dislikes, and even their perception of which is more efficient, which is more accurate, which is more comfortable to use. And a lot of times those 2 things don't jive, right? I mean, they might give something like high marks for something that they really like that they think is easier to use, and we might have really good video evidence that it's totally not. So there's a lot of different ways you can dig at that data, and that's what we refer to as subjective data. It's still a great, valid form of feedback, and there's a lot of different tools that you can use. One of the things that we sometimes do is a discomfort tool. If you go to your doctor and you see the little smiley faces, the frowny faces, you know, in terms of how they feel they're doing, right? So we can look at that perception and compare that to what the EMG is actually showing. But the emotional part is important too. And ultimately, a lot of these things have to be factored in, and it's all about trade-offs, right? So we have to factor in what's good for them and their perception of it and how their emotional reaction to it might drive their decision to purchase and their decision to continue using it. Any other questions? Yeah.
This has been very fascinating to me, but I'm curious, it seems like it would be extremely costly to have all of that freedom behind something like this. How do you or how do companies justify the investment, besides the obvious things, but...
Yeah. So...
And what if they say, well, you know, it can be good enough, we don't need you to spend, you know, this many hours on it, we just kind of want it better than it was?
Yeah, absolutely. No, great question. And in case you couldn't hear on the webinar, the question from the audience here was, how do you basically justify, or how can this type of expenditure be justified? Is it expensive to do this type of work? And I guess I have kind of a two-part answer. So one, we kind of pride ourselves on being very pragmatic in the way that we approach this. We know that product demand, the product development cycle demands really quick action, right? So if it's going to take us 4 months to get an answer as to whether this path is better or that path is better, that might be too late, too long, right? So we have to figure out ways that are efficient and pragmatic at getting, if not that full answer, like I said before, 70 to 80% confidence that we're heading down the right path. And a lot of it comes down to the tools that we choose to use, right? So at the very early stages, there's no reason to jump into EMG, right? Some of those more complicated tools that do have a little bit more cost, but even in the terms of this, that was not an expensive study to run. Each of those people were with us for a few hours, and we pulled off the study within the span of a week and the analysis shortly thereafter. So some of this stuff looks daunting, but it's all in how you set it up and what specifically you're going after. So we take great pains to match up the tools and process that we want to use with what's appropriate at that time and what's going to get us the answer that's really keeping us from going forward on the right path. So that's a big part of the thing. There's a lot that you can get from subjective feedback, from subjective information, from questionnaire information, that you might not have to use some of the processes that we use. And in the case of the importance and satisfaction mapping, that's great and easy to do. You're just kind of out there. People are putting things through the paces. I guess the one wrinkle that's really different from us is we really like to do that simulated use. When you're, again, going back to those kind of 4 things that affect you, you can imagine now if you're in a focus group, you know, you're sitting at a conference room table talking about a tool. You don't get to use that. You know, it might not be for use in a conference room, so you don't get that rich contextual information. So we really try to go out there, but we do the same thing with our prototyping, right? We don't wait. If you notice, like, these are really low fidelity mock-ups. We didn't wait until we had, this is the first fully functioning prototype that was capable of dispensing finish. We didn't wait until this was ready to start doing the testing. And the more you can do with low fidelity stuff is less cost for the prototyping, and it's less cost for the type of study that you're doing as well. So what we try to do, a lot of these studies are just a few weeks in duration. You know, for a typical study, depending on who you need to get in front of and who you need to line up, it might take 2 or 3 weeks to recruit the right people. That can be being done while you're making the stimuli. The test itself might be a day or 2, followed by a week or 2 of analysis to get the findings. So it's not necessarily as expensive as you think, but we also don't throw the kitchen sink at every problem from the beginning. Does that kind of answer your question? Yeah.
Can I add more value to what you're saying? Often what ends up happening is that marketing comes back and says, well, what can we actually say about the product? And they end up paying to do analysis like what they just did. And the only thing that can happen when that occurs is to tell you yes or no based on what the market can say about the product. But if you do something like that early enough, that information adds value to the design process, which at the early end is much more important than marketing saying, okay, well, you developed this product, and we need data to be able to say these things about it, and then you do the study to do that. It only tells what your product can and cannot do, essentially, but not what you can do to change it.
Great, Ed. Thanks. Yeah.
Yeah, I had a question. A lot of this stuff that you, the tools you use are for experimental field investigation. I'm curious, I come from the engineering to the computational side, and I'm wondering, a lot of the stuff, in my calculation, the idea of holding things properly, minimizing energy, and I'm wondering, do you think there's a place, and do you use any kind of what's called computational tools as opposed to more the empirical experimentation to figure out the direction you need to go in?
Absolutely. And just as in mechanical engineering, a lot of times you can do kind of back of the envelope calculations. You can do the same thing with human factors. You don't necessarily even wait until you have a low fidelity mock-up. There's a lot of computational analytical approach that we can do. Again, so biomechanics is exactly that. You know, you're applying that engineering rigor to a simulation because you know how to make up the body, you know how to put center of gravities, you know, the lengths of limbs, you can put, you know, the weights that people are going to be dealing with, and you can look at, there are great ways of analyzing the physical impact of that without having to physically test it. So yeah, a lot of times we'll use that early on to get, again, some directional guidance very early in the process.
But I'm not aware of an analytical human body model, which would be a really interesting sort of development. So there's no computational fluid dynamics or finite element analysis for the body that designers can.
There are some, yeah. Mm-hmm.
Yeah, just coming from a robotics field, there's a lot of work in humanoid robotics and analyzing things like forces. Obviously, than a human body.
Yeah.
This idea of using it in optimization from a design point of view.
Mm-hmm. Yeah, the one that was used a lot by the auto industry was jack. It started off as transom jack, and it's exactly that. You can kind of dial in what person you're looking for. Is it male or female? What body size? And kind of account for that. Put them in the situation. A lot of times that software has been used in like load lifting situations. So again, we're kind of industrial applications where it's a really easy to model, easy repeatable task. Inevitably, it comes down to that. For those of you that are engineers, it's kind of analogous to finite element analysis, right? Which is when you have a CAD model of something and you put a load on it and you're kind of calculating the theoretical stress that those members are going to see. It's the same. Both of them are susceptible to the same problem. It ultimately comes down to how high a fidelity is your model, right? So do you understand how that load is affecting the human body? Like how much load they're carrying it, where they're carrying it, how they're carrying it. That will affect, you know, the force that you're seeing on their lower back. So just as with finite element analysis, if you're applying the load to a CAD model in the wrong way, the results aren't very dependable. And it's kind of a similar thing with biomechanical analysis. You need to make sure that your conditions are set right to have faith in. But there are some tools like that. And they're used to varying degrees. A lot of times they're used more in kind of transportation industries and industrial applications. Yes?
I think you addressed it at the end, that what you showed was that your design makes novices act like that.
Mm-hmm.
How does it take experts?
The experts liked it too. So that's a great point, right? So we wanted to make sure that we weren't alienating the people that have been doing this for years, and they're going to continue to do it for years, right? So that was why we kept going back to people that covered the entire spectrum. And that's an important, so there's two really big important things when we're doing any type of human factors research. One, to make sure, again, you're covering the entire base of representative users. And two, just as we went out with these, we didn't put all of our eggs in one basket, right? We went out with a range of solutions. If you just go out with one thing and people will say, I don't like it, that doesn't necessarily give you enough guidance as to how to fix that. A lot of people really struggle to imagine how something can be different. And people that work for a product firm are better or different at doing that than lay people, right? So most people have to kind of experience something, and then they can tell you what's working and what's not working about it. And when we go into the field, we like to have different implementation of triggers so they can compare how this trigger feels versus a trigger like this versus a trigger like this. So we're giving them a range of things to react to. And that, again, gives us richer feedback in much clearer direction. Another question from the web?
How do you consider how consumers understand warnings, instructions, tutorials from a product design standpoint?
Great question. And that becomes particularly important in medical devices, which we haven't talked about that much. So a lot of what we've been talking about is more, consumer products. But all of that needs to be factored in. And just as we start off with low fidelity mock-ups, early on, we still need to give, the people that are participating in this an understanding of what they're supposed to do. So early on, we might be giving them kind of a walkthrough of the new features and how they're supposed to be used. Later in the process, as our products get higher fidelity, we can also start introducing the instructions and the training that would be associated with that, so that without the intervention of the researcher telling them how to use it, can they learn to use it on their own in the way that's intended? So there's great methodologies for doing that. There's ways of testing comprehension of instructions, of on-product graphics, of warning labels. It becomes a question of when that is addressed within the product design process. We always want to keep track of that and make sure that we're leaving, for instance, you can have a great product. If it has to have a warning label, and you haven't thought about that until the end, you might not have a place for that warning label on the product, right? So we're trying to keep an eye on that within human factors, because again, we're conscious of not only the physical interactions that people have, but that cognition, that thought processing, how the product itself is communicating, and whether that's, again, on-product cues or the warning label that's on that. So we want to make sure that that's addressed throughout the entire process. But there's great ways of doing that. That's certainly something that becomes a part of testing for medical devices to make sure that, again, people are going to be using the representative tool and the representative instructions and get the desired outcome. Another question?
How do you measure, or do you measure adoption of the concept?
You can. So there's what's called a longitudinal study, where you kind of keep going back over periods of time to months and months. And we've done that in some of our studies. So in a different custodial type study that we did, we went out initially, gave them a prototype to use. They were trained on how to use it. We collected data while they were using that. And we went back a couple weeks later, after they've been using it for a while. And the things that you learn from going back into the field is how people adopt, so those workarounds that people come up with, right? So we might have intended this to be used one particular way. We might, and that's how we train people. They might have been doing that the first time they used it. When you go back a couple weeks later, a month later, a year later, you see their true behavior, right? Because people figure out a way to make it work for them, and they'll come up with their own technique. And it's a great way of evaluating, okay, is that bad or is that good? Is that something we want to promote or something that we want to prevent? And again, those studies don't necessarily have to be more expensive either. I think a lot of people necessarily think it's going to be like a big clinical study or something that's going to cost millions of dollars, but it fundamentally comes down to what type of research you're doing. If every time you go out there, it's just an hour of data collection. It becomes more an issue of how many people you're talking to. And again, the real beauty of this from a usability perspective, a lot of this stuff you can get good answers with relatively small sample size. So you can talk to 5 to 8 people and get on the right path and get that confidence without having to do 100, 200, 300 people. Yeah.
How do your different clients participate in the process?
So we're very transparent as a company. So we like our clients to be along for the ride. So from the early stages, when we start talking about, we're here in this at the design process right now, these are the things we need to learn. These are the ways we're recommending that we're doing it. And we completely disclose that research protocol and have everybody look at it, explain the benefits of doing it that way, what we're trying to get, what we are going to get, what we're not going to be able to get by doing it that way. Make sure everybody's on board with that. And it's a great opportunity for our clients to kind of lob in additional things. While you're there, could you also see like what type of mop head they're using? Sure, we can do that. We can ask them other questions. A lot of times our clients come and observe the field research and the product testing that we do. You have to be careful with that. You can't overwhelm people, right? So it's a little bit different if you're applying finish for like a room of like 20 people, right? But a lot of times it's not a problem if you have 2 or 3 people in the field. So we like to have our clients generally really like seeing that because it kind of resonates with them. They kind of understand it. They've seen it for themselves, and it makes it much easier to believe the data. But again, like our whole goal with this is to provide concrete data that can guide design decisions so that you know the consequences, good or bad. Right? And again, you're not just falling back to the loudest person in the room yelling that they want the blue one. Everybody goes into it with eyes wide open. One more question from the web.
Does the use of human factors distinguish design concepts from other design?
Yes. Well, yes and no. So there are other design firms that look like us that have human factors factors. So there's 4 of us that do the heavy lifting in our HF department, which interestingly enough is actually, doesn't sound like much, but that's a pretty big group. There's a lot of our medical device manufacturers that don't have 4 human factors people on staff. The one really interesting thing is that people have caught on to the fact that ergonomics and human factors is a good selling point and something you should be talking about. So basically everybody says they do it. It's a question of whether or not they have the depth and breadth of training that comes with our background. So industrial designers also have exposure to human factors and ergonomic principles. Again, not to the depth and breadth of somebody that comes out of an industrial engineering or a biomedical engineering program. Don't necessarily have access to the same tools and methodologies. So you'll find a lot of companies that say they do this stuff, but you have to kind of scratch the surface a little deeper to see kind of really what they're capable of and what they're able to do. We kind of consider ourselves to be a full-service design firm, right? And we think there's tremendous benefit of having all these disciplines. I've already alluded to the fact that we get like kick-ass stimuli, right? Because we can load things with sensors and we can be collecting data while people are, simulating the use of something. And we've found that a lot of times, like the biggest opportunities for knocking the product out of the park come from making sure you bridge those gaps between different disciplines, right? So having human factors and mechanical engineering and electrical engineering and design and strategy, business strategy and design strategy and prototyping all under one roof, make sure that nothing's falling through those cracks. So I don't know how many companies look exactly like us, but there's probably a decent number that if they're a mechanical engineering firm and an industrial design firm, they might have a human factors person on board too. Yes.
When you think of products like the Nest thermostat and the Fitbit, they come with this. Can you talk a little bit about how that phenomenon is in some of your products?
Yeah, it's really interesting. I mean, it falls right into our sweet spot, right? Because it's kind of neck up meets neck down a little bit. And we have a user experience team that focuses specifically on digital product. But just as there's a lot of overlap between human factors and design strategy and business strategy, it's the same between UX and human factors. So we're all kind of looking at that from different perspectives. More and more products are coming up with a digital user interface or an app for that, right? Whether or not they should, right? I often say just because we can do something doesn't mean we should. But there's a lot of people that are trying that. So again, it kind of falls right into our sweet spot because now we not only have the ability to impact the physical device and the interactions that you have with that, but also the digital device that communicates with that and communicates with you. Right? So you can think of if a great product was designed, but the app was done in total isolation, and those people knew nothing about what made that physical device good and that interaction good, you can end up with the net being kind of a crappy product. Right? So we like that. We like that opportunity to, again, bridge that gap and make sure that both are firing. And again, the information that we find in our discovery research up front when we're doing field research feeds perfectly into the digital interface. Because again, you're interested in what that task workflow looks like and what their informational needs are at different times. And how through the design of the interface, we can bring that important information to the forefront of their attention at that time and find subtle ways of pushing other information back so it's not distracting. Still accessible, but not what they need at that point in time. So it really kind of completes the loop. Any other questions? Yeah.
This has been out for a few years.
Mm-hmm.
How is it still in the same form? Has it been iterated on?
It hasn't been iterated on. I believe they're still selling the exact same version. I'm not sure. I haven't checked in since their latest acquisition. Their company has kind of split and merged a couple of times. My bad that I haven't been keeping up on that. But the last we heard it was doing well. And again, the interesting thing about this is they were originally thinking like, let's just give this to them, right? Because what they really want to do is drive the sell of this bib, and this is the little reservoir. It's called a bib, a bag in a box, right? So this is where they make their money. And it is achieving that really well, right? Because it's it's a smaller quantity. It's not quite like the razor blade model, but that kind of approach. But the interesting thing is, like, they wouldn't be able to sell this without the applicator. So it gave them a great entry into a market that they weren't currently in. Any other questions? I feel like I'm keeping you from cheese and beer. So how about this? At this point, we'll just kind of wrap this up, but I'm going to be here. So feel free to come up and ask any other questions you have. I really thank you for your patience. We talked way longer than the 30 to 45 minutes I was anticipating. Thanks again for coming. And those of you that joined us on the webinar, thank you very much for joining us too. I think we're going to sign off.